Good evening. Guys, I don't know if my network today doesn't seem good at all. Can I just get an indication? Comment section. How is the network? Are you guys hearing me well? Am I audible? Is there no glitching? Is there no lag? Is the network fine? Okay. Royal FX Markets says it's good. Okay. Well, if it's good, then I'm happy, because I'm starting to be a bit worried that it may not be as crisp and as clear as I would want it to be. Yeah, because I don't know. I think it's just at the beginning there, it just seemed like there was a bit of interference. Okay. Well, since we're all well and good, I'm happy that we are. Hope you guys had a good day. That you had a reasonably great, good day. I hope so. All right. All right, so let us see if we can't leave the realm of what we were doing yesterday and just see if we can't. I just want to look at a few other possible solve for X type questions. Then thank you so much, Killer B, for the rose from the get-go. Nothing much has started, but appreciate the gift. Yeah, we'll look at some solve for X type questions, just like of a different flavor from what we've been doing, just so that we can see that that people are seeing what they ought to see. So we'll do that. We'll do a few nature of roots type questions, because sometimes those do sneak into question one. I think are worth looking at. We'll look at some nature of roots, and then that is actually also clear. Yeah. Sorry for the delay. Just need to get my bearings right. Once they're right, then we can get kicking, get flowing, if you know what I mean. I hope you guys have had a good day, like I said, and that you're ready for another segment of other examples where we're solving for just a bit more, requiring a little bit more from us. Okay, so I'm going to do two examples. First one, as you can see here, we have 2 plus 2 over 2x, 2 over 2 plus 2 over x minus 1. So far, actually, let me just change this 2 to an x. Yeah, so that this question has a bit more power and flow. So guys, for those who are joining in for the first time, we are doing a grade 12 build up to the trial exams. Okay, grade 12 build up to the trial exams. So we are doing questions that are related to the first question in the exam paper for paper 1. I just need to get an indication that once again my network is fine, because like I said, my network, I don't know, just from where I'm standing, it seems to exhibit a bit of instability. So I need to be clear with my audience, or I need to just get a sense that please just at every turn let me know if it's fine, if everything is fine. So we're doing a build-up. Like I said, we've done a few questions in previous lives. Yeah, that's what I thought, Mon. That's what I thought. I did think it's a bit unstable. It's doing funky stuff today. It's almost as if like it's fighting with everything that it possesses against whatever is happening today. So it's a pain. It's a pain. It's a pain. But it's fine. Let me just see if I can't change it up a bit here. So that's what will happen. Okay, I seem to have a bit of stability when I have it on here. So it seems like it wants me to actually switch to this side. It says good connection from my side, so I think we can now fly. Alright, so we have x plus 2 over x minus 1 is equal to 4. Hey, you see, this network. You see, this network today. Our network is fighting today, guys. X plus 2 over x minus 1 is equal to 4. We are asked here to do what? To solve for x. So, the only problem we have here is that we have a fraction. And in the fraction that we have, the denominator, where we have a variable in the denominator. Okay, so the expression we have in the denominator is x minus 1. All right, so in order to solve this equation, we need to first make sure that we get rid of the denominator. And the way that we do that is by first and foremost looking at the denominator, factorizing it if possible. All right, and I just want to write those steps down here. Okay, we would look at the denominator and then we would factorize the denominator if possible. But in this particular situation, we can see that the denominator is as simplified as can be, so we cannot factorize it. Okay, but that's what we normally do whenever we have a fraction equation and there's a variable. And by variable, guys, I mean a letter of the alphabet in the denominator, the letter of the alphabet that we're trying to solve. If there is one, then we make sure that we first look at the denominator and see if we can't what? Factorize if possible. If not, then step number 2 is that we need to find the LCD. Now, for those who don't know, LCD is just an acronym that means lowest common denominator. So if you come here, guys, x minus 1 is the only denominator with a variable that we have. X has an unseen denominator, which is 1, and 4 has an unseen denominator, which is 1. So to find the LCD, we are going to have to write down the LCD, which in this case and situation is x minus 1. 3. We need to then write down our restrictions. Write down our restrictions. Now you're going to be asking me, what do I mean by a restriction? Listen, guys. If you look at this fraction, right, there is a value of x which would make this fraction undefined. We substitute the value of x, would first and foremost make this denominator 0, And we know that when we divide a number by 0 is undefined. All right. So we want to look for that value of x which would make the denominator of this fraction be 0. All right. And so we know that the value of x that we could substitute here in the denominator, which would make this fraction 0, is 1. If we substituted 1 in the place of x, minus 1 would lead us, or lead the denominator to becoming what? 0. Okay, so is really not kind today. All right, it's not kind. Okay, but I hope you guys understand that, as I had said earlier, that if we look at this equation, first and foremost, we check the denominator. And if the denominator, we are able to factorize it, we go ahead and we factorize the denominator if possible. But if not, then the next step would be to find what we call the what? The lowest common denominator. And here we can see that the only denominator that is there for this equation is x minus 1. So our LCD is x minus 1. Step number 3, okay, is that we want to write down the restriction. Okay, thank you in the comment section, and I'm glad you guys picked up that error. All right, when we write down the restriction, of course, what value of x, if we substitute in the denominator, would make this entire denominator be 0? We know that that value of x that we would substitute would be positive 1. So we know then that x cannot be positive 1. Okay, x cannot be what? Positive 1. That is our restriction. Then step number 4, we multiply each term in the equation by the LCD. We multiply each term in the equation by the LCD. And when I say we multiply each term in the equation by the LCD, we multiply that LCD in the numerator of the equation. All right. So what I'm going to do is that x is my first term. What I'm going to do is I'm going to multiply x by the LCD, which I know the LCD is what? X minus 1. So I multiply this x by x minus 1 plus, that's my first term, I've multiplied it. 2, I multiply by x minus 1. But I'm sure you remember that there was already an x minus 1 in the denominator, so that's fine. I multiply the 4 by x minus 1 as well. Okay, what does that then do for me? It does the following. This x minus 1 and this x minus 1, you divide the x minus 1 by itself, we are left with 1 and 1, because x minus 1 divided by x minus 1 is equal to 1. Okay, and then of course what's left over? We are left with x into x minus 1 plus 2 times 1, which is equal to 4 into x minus 1. Now we no longer have the denominator, which is great, because now this affords us the opportunity to then be able to do what? To expand, simplify, and get our standard form. Expand, simplify, add and subtract like terms, that means, and then we attain our standard form. So let's see. What's x times x? We get x squared. X times negative 1, we get negative x. 2 times 1 is 2, equal to 4 times x is 4x. 4 times negative 1 gives us negative 4. Okay, and then now what do? We transpose so that we can add and subtract the like terms and get our standard form. So x squared minus x, we then transpose the 4x, we get negative 4x plus 2, we transpose the negative 4, positive 4, and then obviously the like terms there are x squared minus 5x plus 6, which is equal to what? To 0. Okay. Then at this stage, what can we do? We can go ahead, because we have our standard form, we can factorize. And I'm hoping all of you at this stage are like, well, we are in familiar territory, so there is no problem with that, sir. Factorization is not a pain at all. Our factors of 6, we know that we have to have same signs in our bracket. According to what? According to the sign of the middle term. So that means we're going to have a negative and a negative. The factors of 6, if we multiply, we get 6. We add, we get negative 5. We know that is 3 and 2. Not 6 and 1, but 3 and 2. That works, because negative 3 times negative 2 does give us positive 6, and negative 3 minus 2 gives us negative 5. So that works out nicely. Then let's not forget the x and the x equated to 0. We can now apply the 0 factor law, which then means that x minus 3 is equal to 0, or x minus 2 is equal to 0. That is the 0 factor law. We then can write the independent roots of our equations that are linear. So x is equal to 3, or x is equal to positive 2. Okay. So step number 6 was that after expanding, simplifying, and getting our standard form, we factorize, failing which we can always use the quadratic formula, hence QF. 7, we then apply the 0 factor law. 8, we get our roots. Then 9, we check against the restriction if all roots are valid. We check against the restriction if roots, in other words the solutions, are what? Are valid. Okay, so if you look at these values of x is equal to 3 and x is equal to 2. Remember that we said our restriction is that x cannot be positive 1. Why did we say x cannot be positive 1? It is because in our denominator we could clearly see that if the value of x in any way becomes 1, that means 1 minus 1 is 0 in our denominator. We cannot have that. Why? Because division by 0 would imply that our equation is undefined, because the fraction is undefined. Division by 0 in numbers is not allowed because it leads to things being undefined. So we need to avoid that. Hence, when we've written our LCD, we write our restriction. And then our restriction, when we look at our final answer, we go back and check, does the final answer flow and stand true and does not fight against the restriction? And as you can see, guys, x is equal to 3 and x is equal to 2 does not in any way resemble our restriction. If there was an x is equal to 1 here, we would have to actually negate, or we would have to invalidate that particular root. But in this situation, all roots are accepted, all roots are okay, and all roots actually qualify to justify our answer. So that's one example I wanted to do. I'm going to do a second one, okay, so that you guys can actually more fully appreciate, like I said, these fraction type equations, and I wrote the steps here for the purpose of you understanding that for these types of questions, when you have fraction equations, you have to look at the denominator of each term and see, is factorization possible? If it is, you factorize. 2, you then find your LCD. 3, you write down your restrictions. Very important to write down your restrictions. 4, you multiply each term in the equation by the LCD. 5, you expand, simplify so that you can get your standard form equation. 6, you then factorize, or alternatively, you can apply the quadratic formula. 7, apply the zero factor law. 8, write down your roots. 9, check against the restriction if the roots are what? Are valid. And these are very important steps in being able to do these kinds of problems. I'm going to do one more problem so that we can better appreciate these sorts of problems. So I'm just going to turn over the page and then let's look at another question. 2x minus 5. This one a little bit more meaty, you know. One more. Minus 1 over 4 minus x is equal to 7 over x squared minus x minus 12. Okay, so once again, a second example where we have a fraction equation where there's obviously expressions in the denominator with variables in them. So if we revert back to the steps that I've indicated to you we can follow in order to solve these sort of problems, this kind of gives us a guideline so that we know how to approach a question that is of that nature when we come across it. So the first thing is to look at the denominator of the fractions that we have for each term and factorize the denominator if possible. Then find the LCD. So let's come here and check. If we look at the first fraction, we have 2x minus 5. It's over x plus 3. Is x plus 3 something that we must factorize? Should we factorize it? X plus 3, is it factorizable? Okay, so I'm sure you can see that x plus 3 is as simplified and factorized as possible. So we move on then to our second term, which is 1 over 4 minus x. Now, if you look at 4 minus x, there is a bit of a issue that one might take with 4 minus x, something that we have seen and looked at before in previous questions when we were solving for x in certain equations, even with inequalities, when there's two brackets opened and we see that our terms are basically, the order is not as what we would want it to be. The constant term is first, followed by the variable of x with a negative coefficient. I'm sure you guys can remember that there is a certain procedure of factorization we apply to ensure that the x value comes first and the constant term follows. Do you guys still remember the procedure? I even acronymed the procedure for us, you know, in the lives that we have done, I think probably 2 lives ago. Okay, what would we do here? We would apply what I call SCR, sort of like CPR when you want to resuscitate an individual that is basically gasping for air and basically cannot breathe properly, probably no oxygen flowing within the system. So we call it SCR because we see a disorder here that the x term, which is negative, and the constant term is before the x term. So what we do is we apply what we call S means sign, C means change, and R means rule. We apply the sign change rule. Okay, it's a form of what I would call factorization. It ensures that the order of the terms is what we would want it to be, especially if there's a negative x term. Okay, so if we rewrite then the equation, and I'm just going to practically do this. This negative sign is still intact. We have 1 over this 4 minus x. What we do is we swap around the x and the 4. And then what we do is we take out a negative sign. Now, please take note what this does to our expression in the denominator. We took out a negative sign, right, guys? If you take the negative sign back, negative times x, doesn't it give you back the negative x? Yes, it does. What about negative times negative 4? Don't we get a positive 4 back? Yes, we do. So therefore, taking out the negative sign is just simply a procedure we perform called the sign change rule, and it allows us to factorize this expression so that we have the correct order, the variable followed by the constant term. And we do this all the time whenever the two terms are separated by a negative sign and the second term is our variable. Sign change rule works like a charm every time. So now the situation you are finding yourself in is that you have two negative signs that are following each other, and these two negative signs have a relationship of multiplication, and negative times another negative. We are going to resolve that sign and get one actual sign so that we proceed with the problem with no two signs following each other, because if we have that, it does present a problem. So that is a form of factorization that we apply to the binomial terms in the denominator. Let's go to the last term on the other side of the equal sign. The denominator there, can we factorize the denominator of x squared minus x minus 12? Is it factorizable? Siamtanda says yes indeed. I agree wholeheartedly. So let's go ahead and factorize then. Okay, opening two brackets as we usually do. The factors of 12. This time round, our sign of the constant term is negative. That means that the brackets will have different signs. Minus for your constant terms means we have different signs in the bracket. And this minus sign says the highest factor of the factors will have a negative sign. So if we think about the factors of 12, we have 6 and 2, we have 4 and 3, we have 12 and 1. Which one helps us to be able to get this combination intact? Because remember, the negative sign means we have different signs. So there's a negative and a positive sign that should be there. And we said that the highest factor should have a negative sign. So which factors do we choose? 12 and 1, 6 and 2, 4 and 3. So I'm sure you guys can see clearly that 4 and 3 qualify the best. Then we just slot in the x and the x, and that basically means we are good to go and proceed to the next step. So if I now complete step number 1 of the steps towards solving this question, having factorized all I could in the denominator, now resolving and wanting to resolve the signs here, I'm going to have a positive 1 over x minus 4, which is equal to 7 over x minus 4 into x plus 3. Guys, my factorization mission is now complete. That means step number 1 has been successfully done and dusted. Step number 2, after factorizing the denominator, what do I do next? What happens next after factorizing the denominator? I need to then find what, guys? Tabolebus was saying it very nicely in the comment section. We need to now discover what the lowest common denominator is. All right. And lowest common denominator simply means this, guys. It simply means that I am going to identify in the denominator the common brackets. Okay, the common bracket that has the highest exponent. I repeat, the common bracket that has the highest exponent. Okay, so if I look at x plus 3, okay, x plus 3 is common for 2 of my fractions. And since it is common for 2 of my fractions, I see that this x plus 3 has the exponent 1. This x plus 3 also has the exponent 1. So that means for my LCD, I am going to identify x plus 3 as one of my lowest common denominators. If we take a look again in this particular fraction equation, I can also see that x minus 4 is common, okay, for 2 different fractions. And as it is common, we can also see that the exponent, this is x minus 4 to the power 1. This is also x minus 4 to the power 1. It is common as x plus 4. So I write the x minus 4, as a product together with x plus 3. This here is my lowest common denominator. X plus 3 into x minus 4. All right. So that's how I was able to identify the LCD. Then what follows? I need to write down my restriction. Okay. The values of x that x cannot be, because if x is that particular value, it would mean that my denominator will be 0. So for this bracket, x cannot be what? I'm sure you guys can see. What value would I substitute here which would make this bracket 0? Okay, what value? So x cannot be what here? -3. All songs is just answered in the comment section. And then for this bracket, what value of x can x not be, because it would make this denominator 0? Okay, so I want to avoid the value of 4. So 2 restrictions. X cannot be. And guys, when you have your LCD properly written, okay, you would actually find that, oh, this LCD that I write, my restriction is written from the LCD, because for this first bracket, which value of x will make this bracket 0? It's when x is equal to -3. So x cannot be -3. Or what? If you look at this bracket, what would make that bracket 0? This one. It's when x is not 4. Okay. All right. I hope you understand that. So we write our LCD, and please guys, write down your restriction immediately after writing down your LCD. Please, please, please. It is a step that many learners tend to omit, and when they do, it leads to them not being able to actually write down the correct answer at the end, okay, because they have nothing to check against. All right, so please write down your restriction immediately after your lowest common denominator. Next step, after writing our restriction, we can now multiply each term, this term, this term, this term, by the what? By the LCD. Okay, and when we do so, that should lead to a cancellation of the denominators, so that we do not have fractions anymore. So I want us now to just use all of these next to all of, because it would be long. But I want you to recognize that if I took this x plus 3 into x minus 4 and I multiplied it here at the top, which bracket would disappear because it would cancel with x plus 3? It would be this x plus 3, right? Okay, so this x plus 3 would cancel with this x plus 3. Are you with me? And then what would be left over? X minus 4. So that would mean 2x plus 5 will be multiplied with x minus 4, because the x plus 3 would cancel this x plus 3. Okay, I hope you guys are with me and you understand what I am saying here. Because we multiply each term by the LCD, x plus 3 and x plus 3 would cancel, but x minus 4 gets left behind to be multiplied with 2x plus 5. Okay, all right. I think now, for the benefit of those that say they don't understand, remember, what did I say? I said we multiply each term by the LCD. So I'm doing this for those that don't really get it. I found the LCD, so now I multiply this fraction in the numerator by the LCD. But then what do you see? This x plus 3 and this x plus 3 will cancel each other, because this x plus 3 is in the numerator, this x plus 3 is in the denominator. Something divided by itself gives us what? 1. Are you with me, guys? So that's why then what gets left behind? 2x plus 5 multiplied with who? x minus 4. There it is. I've just written down here in this step what is left behind. Then we proceed. We do the same thing here. We take the LCD that we identified, we multiply by it in the numerator. Who's going to get cancelled? If I take this LCD x plus 3 into x minus 4 and I multiply here at the top, who gets cancelled out? Who gets left behind? You know, unfortunately, it's like life. Some people get cancelled out, some people get left behind. It's like in your life, you'll have a group of people that you know, but at the end of the day, some will get cancelled out, some will get left behind. Okay, so Samantha, you are right. X minus 4 will be the one that gets cancelled out. Then who gets left behind? It means x plus 3 is going to get left behind. So I'm going to say 1 into x plus 3. That's who got left behind, because the x minus 4 cancelled x minus 4. Are you with me? Okay, equal. Okay, now we do the same thing here. We're going to multiply by the LCD. All right, I want you to understand. All right, I'm doing this like off the top of my head, but we are practically taking this x plus 3 into x minus 4. All right, and you are multiplying by the LCD. Who gets cancelled out, guys? Now I'm sure you can see that both get cancelled out. So who gets left behind? Just 7. And this was what happens. Sometimes this is exactly what happens. The very things that you think you are going to take with you, you know, they get cancelled out by other things, and sometimes you get left behind alone. You are the only one that's pushing, you know. Sometimes some things get left behind. Sometimes it's like another thing that you didn't anticipate gets left behind. All right, yeah, and it takes wise people to realize that, oh, okay, maybe that thing, it just wasn't. Some people are there for a season. Some people are there permanently in our lives, so we just need to accept it when it is the case. All right, so this is just, sorry man, just a lesson in there, because you know, it's nice when we do these things. LCD, we multiply each term by the LCD, and that basically is multiplication in the numerator, but that is supposed to do what? Eliminate. All of this is helping us to eliminate the denominator, so we have a simplistic equation that we can solve. Now we are here, guys. Now we are here. I think now from here, from here, it should be straightforward, because this is like a typical equation we've been doing since day one. Okay, so you're going to now multiply out, okay, simplify, get your equation into standard form. Okay, so this and that get multiplied, you do the FOIL. All right, 2x times x, 2x squared, 2x times minus 4x. Just remember, when you're multiplying these things, 2x times minus 4. I always tell my learners that when you multiply, you must remember this. Okay, if you are watching movies right now, or at least like if it's you've been watching movies, I hope you always avoid these kinds of movies, the ones that have S, N, and L. They don't really go down well, you know. Like I've never seen them going down so well, so it's always a good thing to avoid them. But what the S and L means is that when you are multiplying out in maths, you must always consider multiplying out the sign first. So the S stands for sign, guys. If you were thinking that it stands for something else, I was saying avoid the movies, but through the S and L, we can understand that when we multiply out, we must multiply the sign, meaning we must think of the signs when we multiply. Then we must multiply the number in that order. And then L, we must multiply the letters. Make sure that the letters are multiplied out, the variables. We apply the appropriate law when multiplying the variables. That's the letters of the alphabet we're talking about. So for instance, when I multiply 2x and x, in my head, I'm like, a positive times a positive, because that's the sign, is a positive. Then I follow it with the number. 2 times, I recognize that there's a 1 here that I cannot see. 2 times 1 is what? 2. Then x times x. You see the letter now. X times x, I keep the base, I add the exponents. There's an unseen 1 at the top here and an unseen 1 there. So 1 plus 1 in the exponent gives me 2. That's what I mean by recognition of multiplication of sign, multiplication of number, multiplication of letter. Always be mindful of that when you are foiling. So as I finish off, what's 2x times minus 4? Positive times a negative, that's a negative. Okay, then 2 times 4, that gives me 8. Then the letter x next door. 5 times x. 5 is positive, the x is positive. What's positive times a positive? That is positive. Then what's 5 times 1? That is 5. Then x next door. Then lastly, 5 times negative 4. Positive times a negative, that's negative. 5 times 4, that is 20. Okay. All right. So I hope you guys are feeling me about this sign, number, letter mambo jimbo. Okay. Star Christie, the live started at just after 10:30. So the 10:30 for, yeah, we've just sort of like gotten into a habit of doing because we build. This is all a build up for the grade 12s that are writing their trial exam. So I'm just trying to get some paper 1 content in. People need to start familiarizing themselves with that. Okay, and it's every day, Star Christie, every day. So we'll see how far we'll go today. I do realize that some people need to wake up tomorrow morning, but nonetheless, we'll see how far we can push today. 1 times x, 1 times 3. Let's transpose the 7 so that we have equal to 0. Okay, equals to 0. Livia is asking why you always focus on paper 1, sir. Like I said, I realize that some people that are in this live haven't been doing, it's been a long time since they've done maths. Okay, I have people that are writing in November and towards the end of this year, so the maths might not be as sweet and cool as it used to be, especially for those who are doing rewrites for end of year November. So the reason why I'm actually doing this is so that they can actually follow along. All right, so I'm going to gradually move away from obviously the topics that I'm doing question 1 and move on to other questions and other topics. Okay, and at some point I'll get to paper 2. Yes, Sinclair, it will be on YouTube. I'll post it when that time comes. Okay, so yeah, but please don't let me hold you back. If at least you've kind of gotten catalyzed by being in the live, don't hold yourself back. Go ahead and go and practice on the side and go and do the questions that are crying for your attention. Negative 8x plus 5x, okay, plus x. What's negative 8x plus 5x? It's negative 3x plus x. That gives us negative 2x. Okay. And then last but not least, negative 20 minus 7, that's negative 27. Negative 27 plus 3, that gives us negative. Okay. Yeah, Blue Car Clark is like saying algebra question 1.3 is my enemy. Yeah, well, algebra question 1.3 is people's enemy because they obviously throw a spanner in the works there. But if you have a good, sound, basic mathematical knowledge and understanding, question 1.3 doesn't matter how it comes. You should be able to actually get out of the woods with those kinds of questions. Doesn't matter how they come. It depends on the person. So 2x squared minus 2x minus 24 is equal to 0. Obviously, we can see that there is a highest common factor. So we divide by that highest common factor. We get x squared minus x minus 12. Okay. You see? So we divide by that 2, definitely. Then of course we factorize. Factors, negative sign means different signs, but the highest factor is going to have a negative sign, so it's negative positive. Factors of 12, yes, Tabo, we have 4 and 3. Negative 4 and 3 is equal to 0. Then last but not least, we solve for x there. Okay guys, zero factor law. Factors, if factors are equated to 0, we can independently write them equated to 0, and then we can solve the linear equations. So we get x is equal to 4, x is equal to negative 3. Okay, my mistake there. X plus 3 is equal to x equal to negative 3. When we are here, we go and we check our answer against the restriction. Go and do what? Check what? Your answer against what? The restriction. Why? Because that's how things are done with these kinds of questions. Okay, that's how things are done with these kinds of questions. Okay, just want to check back and see if all of my mathematics was done correctly before I conclude. All right, because you know what, I am prone to mistakes myself. I'm not perfect. I don't claim perfection, so it's always nice for me to go back and check if my maths was done correctly. Okay, and if you pay very close attention, you'll realize that there's an error that I made. Okay, pay very close attention. Do you see 2x minus 5? 2x minus 5. Do you see what happened here? Have you guys ever done this yourselves? You are writing the paper, man, the maths is flowing very nicely, and for some reason or another, you just happen to change something in the question. Do you see what happened there, guys? No one in this live actually said, sir, no, you did not just change the signs to something that is not there. No one picked it up. Look at you. Blue Clock is saying I did that in trig identities. I know you didn't see, because you know when they, what is it? It's like I've cast a spell on people, and people are just sort of like saying, no, we can rely on this guy. Okay, so please do make it a point that whenever you are seeing me do stuff, just check that I am not altering things, you know, because look, this here is dangerous. This is something that I think, you know, as I mark learners, even myself, I slip. This is a typical slip, you know. This is a typical slip where the sign just changed for some reason. Okay, so I'm happy that I made that error, not because making an error is good, but because learning curve. Okay, no, teachers are not always right, please. Okay, teachers are as human as can be, so if you can make an error, teachers can make an error. There's no such thing. We are not infallible, unfortunately. Okay, no, we are not going to restart. The only thing that needs to happen here is we need to actually change that sign there. But you know that if you had done this, you would have to actually obviously cancel all of this out, because all of this is irrelevant. Okay, you'd have to cancel it out. You know, cancel it out nicely, very nicely and neatly, and then you rewrite. So what I'm going to do, I'm going to just pick it up from where the error was made. Okay, so just be with me here. That 2x minus 5. So I know if it was 2x minus 5, what I would have done, it would have been 2x minus 5 into x minus 4 plus 1 into x plus 3, which is equal to 7. So I'm just going to pick it up from there, guys. Okay, but you know that in a typical test, you'd have to cancel that out up until where you made the error, and then make sure that you do that out. You do that very neatly, okay, and write cancelled, and then you can actually rewrite things from a particular step, or you just make sure that you do what needs to be done. Okay, so if we pick it up from here, guys, because this is where I made the error, this becomes, if I multiply out, 2x squared 2x squared, comment section is cracking me up. 2x squared minus 8x minus 5x plus 20 plus x plus 3 is equal to 7. 2x squared minus 13x plus x, that gives you minus 12x. Then we say plus 20, we transpose the minus 7. Then we basically get 2x squared minus 12x plus 16, which is equal to 0. Then that gives us the opportunity to divide by 2, which gives us x squared minus 6x plus 8. Okay. Then rightfully so, when we factorize, we get x and x. This means that our signs in the bracket will be both the same. Okay. And then the same signs will basically both be negative. Then we have 4 and 2. So then our final answer after applying the zero factor law is x is equal to 4 or x is equal to 2. Okay. Okay, so that makes a bit more sense, from what we did initially. And then what we do from here, we go and check against the restriction which answer is valid and which one isn't. Guys, in our answer we have x is equal to 4 in there, but the restriction says x cannot be 4. So what does that mean? It means we say x cannot be 4 as well, because we are told the restriction says so. Now you see, guys, why it is important to write the restriction. Okay, so that we can make this one invalid. You are invalid, Wena. We don't want you. You are naughty, you. But Wena, we love you. We embrace you. You are the one. Okay, and that's how it is even in life. We invalidate some, we embrace others. All right. So yes. I hope we're good there. All right. So that is just one question that basically we can get, and it's a very common one, guys. Very, very common one that you can get solving for x where it is specifically evident that it's a fraction. And of course, if it is a fraction, then of course you have to apply these procedures so that you can actually make it work. All right, guys, it's okay. Hey, I think all of us, we need to develop a sense of what you might call, they call it emotional intelligence when it comes to people that come into the life. I think naturally, if someone is coming into the life, let's just think about it logically. If someone comes into the life and they see maths is happening, I think it would be natural for them to be like, oh, what are these guys doing, man? It's holidays. I think that's normal. So let's give the people that come in here and they throw their comments a bit of mercy. It's okay. Let's be merciful towards them. It's not too shabby at all. Hopefully they get the picture, and they can just also do the things. I want to do 2 more examples that are not the same as the previous 2 that I've done. Just another one. X squared minus 2x minus 8 over x squared minus 2x is equal to 7. Blue clock, you're asking are prelims easy? Well, if term 2 was not child's play, Blue, then I must say to you that you're just going to have to make sure that you are doing what needs to be done right now. Okay, you are going to have to make sure that you are doing what needs to be done right now. So that's why I'm doing what I'm doing. Hopefully we can be sensitized to realizing that The work that needs to be put in, let it be put in before, there's too much pressure in term 3. There's a lot of work that is being done. So whilst at least we still have a week before schools reopen, let's do something that is memorable, that we'll never forget, that will lay a solid foundation for ourselves. Okay. Yeah. I love what Tabo is saying there. Yes, please, practice. Yeah. 100 days. I was saying to my learners in the province that I'm in that they only have like 55 days. It's literally today 55 days till they write their maths paper 1, according to the timetable that they have, 55 days. And then a little bit more after that, you'll be writing your final. So we need to do some work, that's for sure. Okay guys, look at this example. All right, x squared minus 2x minus 8 over x squared minus 2x is equal to 7. Okay, this type of question, okay, if we were to say, all right, this is a fraction equation again, all right, then what we do is, if we would actually go ahead and apply this method, we factorize the denominator, find the LCD, write down the restriction, multiply each term. There is a problem that we are going to run into. Okay, there is a huge problem we are going to run into, and that is when we multiply the LCD, there is going to be a problem because we are going to be led to an equation that will have as its highest exponent x to the power 4, and that is a problem. It's a serious problem. All right, it is a serious problem. So not all questions that have fractions actually will flow out well if we factorize the denominator, write down the LCD, write down the restriction, then multiply each term by the LCD. This particular situation won't follow down well where that is concerned, because it will lead us to an equation where we have x to the power 4. And I am definitely sure that with the grade 8s, 9, 10s, 11s, 12s that are potentially in this live, we know that when an equation has x to the power 4, we ourselves are kind of not well versed in solving equations of the 4th degree. So then there's something else we need to recognize from the question, and I want you guys to pay attention what that is. So these questions, we call them K-method questions as well. K-method. There's a method that we can apply called the K-method. All right. Now, how do you spot? Hey, what's happening now here? What's happening now here? All right. Now, how do you spot? Hey, what's happening now here? What's happening now here? Okay, I'm sorry about that, guys. Okay, I'm sorry about that. Had a bit of a live intermission there. Okay, can I just ask if my network is also doing funny things? Is my network okay, guys? Can you hear me? Am I audible? Am I glitching? Are we okay? Okay, it's fine now. All right. So K method. How do we glitching, eh? I'm sorry, guys. I really I don't know. 2x minus 8 over x squared minus x is equal to 7. Guys, here is the clue. Do you see this? Do you see that? Repetition of an expression. Repetition. X squared minus 2x in the numerator for a separate term, x squared minus 2x in the denominator for another term. Different, no, same expressions. X squared minus 2x, x squared minus 2x. So that implies that whenever we have a repetition of an expression in our equation, and we can also clearly see that if we were to multiply that LCD, it will lead to an x to the power 4 equation. We immediately turn our attention to the K method. So what do we do here? We simply look at this equation, we take the repetition of the expression, we let K be equal to x squared minus 2x. Aye, that's it. All right. So yesterday we did some exponential equation questions, and there were those quadratic trinomial type questions that needed us to use the K method. I hope you still remember those in your minds, and they are still there. So even with these types of questions here, they are fraction equations, but we cannot unfortunately apply the method that we applied here. We have to use the K method. Why? Because there is a repetition of the expression for two terms where the one expression is in the numerator and the repeated expression is in the denominator of the other term. Okay, so we let K be the repeated expression, and then we go ahead. In the place of x squared minus 2, I'm going to substitute K. K minus 8 over K is equal to 7. Surely this looks a bit more user-friendly, if you want to put it that way. All right. Now we have a LCD, but that LCD is K, makes life very easy. K cannot be 0 as per the restriction. Then all we do now is we want to get rid, it's pretty, Livia. Now we get rid of the K in the denominator by doing what? By multiplying each term by the LCD, which is K. So let's go ahead and do that. We multiply this by K, K times K, minus 8 times K over K is equal to 7K. Imagine if you had that amount of money to actually use for the last few weeks on a holiday. That would be nice, wouldn't it? 7K in the bag. All right. Okay, what's K times K? That gives us K squared. This K and this K, they cancel out. That leaves us with minus 8. Okay, and then lastly there, equal to 7K. Okay. All right, all songs, remember, whether you make it multiply or dot doesn't really matter. Okay, all songs, remember multiplication, there's 3 ways of representing multiplication. You could, I mean, even if I put a bracket, you can either say K times K, that's fine, brackets mean multiply. You could say K, dots mean multiply, or you could say K times K. Multiply also means multiply. So these are 3 different ways of saying the same thing, and all are acceptable. So all songs, it's fine. Okay, if you want to put a dot, please dot away. If you want to put a bracket away. If you, like me, want to put a multiplication sign that it's evident, please, by all means, no penalization will happen because of that. Okay, because all 3 are 100% correct. Take the 7K, transpose it, negative 7k minus 8, which is equal to what? To 0. Okay, then now what can we do? Factorize. So let's open two brackets. We say kk, of course, because k times k will give us k squared. The negative sign means different signs inside the bracket, but the highest factor is going to have a negative sign. Which factors would be appropriate? 8 and 1? 4 and 2? Which one? 8 and 1 or 4 and 2? Okay, all songs are saying 1 and negative 8. Does the grand jury agree? All right, people agree. So 8, which is negative, and 1, who is positive. Then our k values, k is equal to 8 or k is equal to negative 1. Of course, this is coming from the zero factor law. So now that we have our k values, are we done? No. K is the way to x. K is the way to x. This is very important. The k way. K is the way to x. So oftentimes people feel like when they get k, it's like they are done. No, guys. We are not solving for k here. We are solving for x. So k is the way to x. So we come back here to where we let k be equal to x squared minus 2x. And in the place of k, we substitute the k values that we got. Okay, so let's go. X squared minus 2x equal to 8. Or x squared minus 2x is equal to negative 1. Tabo, thank you so much for sharing that. Okay, I think as a former matriculant, I love the fact that you've said in the comment section you used to make that mistake a lot. Tabo, I mark students all the time and they make that mistake a lot of times. They get to k and they're like, yes, yes, yes. And I'm sure like I can see them like celebrating, like 10,000 people watching, you know? Yeah, so it's funny, like all the time. Definitely blue, that is true. So now we can then, after equating x squared minus 2x to the respective k values, okay, we can now solve the respective equations. Get them both into standard form and then solve both of them. Okay, x minus means different signs. Okay, and of course the highest factor is going to have a negative sign for the factors of 8. So what are our numbers there? We know different signs, minus and plus. Factors, guys, which ones? Who is factoring? Who is the one that's going to be blue is like saying this part of algebra is nice. Now it definitely is 4 and 2. Okay, and then if you apply the zero factor law, I'm just gonna go straight to the roots. X is equal to 4 or x is equal to negative 2. Okay, does that make sense, guys? So yes, negative 4 and plus 2 are my factors. All right, and then my final roots for this equation is x is equal to 4 or x is equal to negative 2. So I'm done with solving this equation. Let's go to the other one. X squared minus 2x plus 1. So I'm going to open two brackets as well this side. Positive means what? I have same signs inside the bracket. According to which sign? They both are going to be negative. So let's do that. Minus 1. Okay, let me give you a chance to screenshot the previous one. Dgento. I'm sorry for, I think there's someone who said that the network, Spinara is saying this network is not giving. Spinara, I'm going to post these videos onto my YouTube channel. It's just that I don't want to re-explain it's going to make the video too long. So you're just going to have to go to the channel after I'm done, and you can rewatch it at your own time. It's just that time is of the essence right now. I can't really be spending too much time on this. I'm sorry that your network is not treating you well today. Very, very sorry. I hope you screenshotted. The person wanted to screenshot. Final answer here. Okay. You can see it's x is equal to 1. Okay, and I mean, this is the same answer. X is equal to 1 here. We get x is equal to 1 from this bracket. We get x is equal to 1 from this bracket. So we can just write x is equal to 1. That's it. Done, dusted. Okay. All right. So there is that problem. Okay. Okay. Yeah. Tabolebuso, it is when the signs are different. I mean, when the sign of the constant term is negative, the implication is that if the sign for the constant term is negative, that means different signs in the bracket. Then this sign here will tell us what sign the highest factor will have. This sign will tell us which sign will the highest factor receive. So since it is negative, that's why the highest factor is receiving the negative sign. But if this sign was positive, whilst the constant term is negative, then the highest factor would have received the positive sign. Okay, so that is the rule that applies for when we have a negative constant term, because a negative constant term always implies we have different signs, and then this sign will say to us the highest factor gets the sign. On the other hand, when we have positives always says we have the same signs inside the bracket. That's what positive constant term says. We have the same signs inside the bracket, and it will be the same according to this. Okay. So yeah, to my grade 11s, of course, we are wanting to make sure that factorization is something we can do, right? So that's why we make sure that we do it. But as for my grade, the grade 12s, yeah, you guys have the liberty of actually doing quadratic formula factorization, but grade 11s need to get into the swing of things of factorizing. All right, and I mean, factorizing is a skill you need to have, because there's certain instances where you cannot avoid it, But I know some people, obviously, like Livia yesterday showed us, and I think others showed us that they are well able to use the quadratic formula in the calculator, get the roots, and then sort of like rewrite them back so that they get the factors, and then write the roots, after having written down the factors, working back. Okay, so that was one question that has to do with K. I want to show you another one that basically also involves Mr. K. Mr. K is a very I'm sure you guys will immediately, when you see the question, see, oh, okay, this one is also always easily. Okay, can you see, guys, once again, remember the concept I said, the repetition of a particular expression. Yes, this is a third expression, which means this is a third equation, but square root of x minus 1, square root of x minus 1 for different terms is repeated one instant in the denominator, the other instant term as a numerator. So what can we then apply here to solve for the equation? We can also apply what here, guys? Do you see what I'm saying here about Mr. Method K? Mr. Method K is here to save us whenever there's a repetition in the expression for different terms, and we can clearly see that repetition. So K method is there for you. All right. Why don't I allow you guys to do this one? and then someone can guest request, or you can guest request now. You can lead me, and you can do it. I think that would be nice. I'm kind of tired of hearing my voice. I don't know. I know sometimes when people hear someone's voices for too long, yeah. Okay, too sweet. The problem. Okay, so what do we do here?